Hello and welcome to the video lecture on trigonometric Fourier series for the given waveform. This waveform is a rectangular waveform having an fundamental period of t0, amplitude is a, and the on time is between the limits minus tau by 2 to plus tau by 2. So this is all given information in the waveform. And now we'll try to represent this time domain signal, periodic signal, into the Fourier series representation, which is a trigonometric form. So let us first write the equation for the trigonometric Fourier series. So the equation for trigonometric Fourier series is given by the formula x of t is equal to a0 plus summation n is equal to 1 to infinity an cos of 2 pi nt divided by t plus bn sine of 2 pi nt divided by t. So this is the equation, and in this we are going to find the coefficients a0, an and bn. So let us first start with calculating the coefficient a0. The formula for calculation of a0 is given by 1 upon t integration over the period t x of t into dt. Now let us substitute all the values in the equation. Now from the waveform it is clear that the value of capital T is t0. Limits will be from minus tau by 2 to plus tau by 2, and the x of t value, that is amplitude, is a. Now as a is a constant term, we can take it outside the integration, and therefore the outside term will be a by t0, and the limits from tau by 2 minus tau by 2 to plus tau by 2 integration dt. But the integration dt is nothing but it is t, limits from minus tau by 2 to plus tau by 2. Now let us substitute the limits. So a divided by t0 tau by 2 minus of minus lower limit. So which is equal to a divided by t0 tau by 2 plus tau by 2. So which is equal to a divided by t0 2 tau by 2. So 2 gets cancelled. So it is a into tau divided by t0. So this is our first coefficient, that is a0, that is a into tau by t0. Now let us calculate the second coefficient, which is an coefficient. Now the formula for calculation of an coefficient is given by 2 by t integration over the period t x of t into cos of 2 pi nt divided by t into dt. So this is the formula. Again we'll substitute all the values. So 2 divided by t naught integration minus tau by 2 to plus tau by 2. X of t is a into cos of 2 pi nt divided by t naught into dt. Again a is a constant term, so take it outside the integration. So 2a by t0 minus tau by 2 to tau by 2 cos of 2 pi nt divided by t naught into dt. Now all of we know that the integration of cos is a sine term. So 2a divided by t naught sine of 2 pi nt divided by t naught divided by 2 pi n by t0, limits from minus tau by 2 to plus tau by 2. So this t0 2 gets cancelled. So here you will get a divided by pi n into sine of 2 pi nt divided by t naught, limits from minus tau by 2 to plus tau by 2. Now let us substitute the limits. So a divided by pi n into sine of 2 pi n into tau divided by 2t0 minus sine of 2 pi n minus tau divided by 2t0. But sine of minus theta is always equal to, here we have a trigonometric identity, sine of minus theta is equal to minus sine theta pi n into sine of this 2 and 2 gets cancelled. So pi n tau upon t0 minus minus will make this term plus. So plus sine of pi n tau by t0. So sine pi n tau by t0 plus sine pi n tau by t0 results in 2 sine pi n tau by t0. So which is equal to 2. I will take outside this. So 2a divided by pi n into sine of pi n tau divided by t0. So this is the equation for an. So this is our second coefficient, that is an coefficient. And now we'll go for calculating the third coefficient, that is the bn coefficient. The formula for calculation of bn is given by bn is equal to 2 by t integration minus tau by 2 to plus tau by 2 x of t into sine of 2 pi n t divided by t into dt. Again we will substitute all the values. A into sine of 2 pi n t divided by t naught into dt. So A is a constant term, so 2a by t naught into minus tau by 2 to tau by 2 sine of 2 pi n t by t0 into dt. Now we know that the integration of sine is minus cos. So minus cos 2 pi n t divided by t0 divided by 2 pi n by t naught, limits from minus tau by 2 to plus tau by 2. Again t0 2 gets cancelled. So a divided by pi n into minus cos of 2 pi n tau divided by 2 t naught minus cos of 2 pi n minus tau divided by 2 t0. And we know that according to the trigonometric identity, cos of minus theta is always equal to cos theta. So the second term will make this cos of minus tau is equal to cos of plus tau. So it becomes a divided by pi n into minus cos of 2 gets cancelled, pi n tau divided by t0, and this is also minus cos of 2 pi n tau. 2 again gets cancelled, so it is pi n tau by t0. So this cos and this cos gets cancelled and therefore value is 0. Therefore the coefficient bn is equal to 0. So these are all coefficients of the trigonometric Fourier series, and then we are going to put all these values in the standard equation, and then we are going to write the final equation for x of t. So now let us substitute this value of a0, an and bn in the trigonometric Fourier series, and let's see what is the final answer for this rectangular waveform. So x of t is equal to a0, value of a0 is a into tau by t naught plus summation n is equal to 1 to infinity value of an. And what is an? An is 2a by pi n sine of pi n tau by t0. So 2a divided by pi n into sine of pi n tau by t naught into this term, that is cos of 2 pi n t by t, but t is nothing but t0 and bn is 0. So this term will be 0. So this is what is the representation or trigonometric Fourier series representation for the given rectangular waveform. So if you like my video, then please share the video with your friends, and still if you have not subscribed to my channel, then please subscribe to my channel. Thank you guys. Thank you so much.